Welcome back. In this video, we are going to study the law of cosines. Recall when we studied the law of sines that we wanted to make sure our triangles made sense. Well, with the law of cosines, we're going to want to apply those same skills. So make sure when you solve your triangles, you see that the largest side will be opposite the largest angle, the smallest side will be opposite the smallest angle, and of course the medium side will be opposite the medium-sized angle. And also with the law of cosines, as with the law of sines, you have to think about triangles. We may still have some triangles that don't make sense. So be sure that in any triangle, the sum of the lengths of any two sides must be greater than the length of the remaining side. That situation where triangles collapse onto itself. So recall that when we proved triangles congruent and when we used the law of sines, we were looking for particular combinations. We were looking for angle side angle or angle angle side, or we also did side side angle with the law of sines. Okay, so to solve triangles with angle side angle, angle angle side, and side side angle, we used the law of sines. So we had information about two angles and an included side, or we had two angles and a non-included side, or with side side angle we had an angle and two consecutive sides. So here, for these three, we use the law of sines. Now, moving forward, if we have side angle side or side side side, we would use the law of cosines. Okay? So if we have no angle measurements, and we have just the measures of three sides, we know side A, side B, and side C, well, we have to use the law of cosines. You may remember with the law of sines, we had to have at least one angle. And with side angle side, same situation. We have two sides and an included angle, so we might have side A and side B, angle C. Well, we don't have enough information here to be able to do the law of sines. So for these two situations, we'll use the law of cosines. So I'm going to present the law of cosines. I'm not going to prove it for you. The law of cosines in any triangle ABC with sides A, B, and C is side A squared will be equal to side B squared plus side C squared minus 2BC cosine of A. Law of cosines with respect to angle B, and we have the law of cosines with respect to angle C. So we really have three versions of the same thing. Which one of these you use will depend upon the information that's provided for you. Okay? And if you think these all look a little like the Pythagorean theorem, you're correct, because we did use the Pythagorean theorem in establishing the law of cosines. I'm not going to prove this for you. How I remember or memorize the law of cosines, if I'm working from angle A, then I know that I'm going to have A squared. Okay, or if I'm working with angle B or side B, then I'm going to use the B version. Or if I'm working with side C or angle C, then I'm going to use the C version. So there's this connection between the cosine of whichever angle I'm using and, of course, what I'm setting it equal to, the square. So if I've got angle A, then I'm going to, and I have, or I'm trying to find side A, I can use the A squared version. Now, whether I have B or C here, or A or C, it's really just the rest of the Pythagorean theorem. It's the other two sides. So I have B squared equals A squared plus C squared. And then this business here, the 2AC or the 2BC, you'll notice that if I'm finding the cosine of angle A, or I have the cosine of angle A, B squared, C squared, these match up. This BC and this BC, B squared, C squared. Or this AB, then I have, going to use A squared, B squared. So if you can make those connections, it'll be a little bit easier for you to memorize or certainly recognize which law of cosines you want to use. So let's take a look at the law of cosines and see how it works. We have a given triangle ABC. And A is 11, and C is 9, and B is 6. We want to find the measure of angle C, so we have to use the law of cosines because we have side, side, side here. We want to find the measure of angle C, so we're going to use this last law of cosines. So we will do C squared equals A squared plus B squared minus 2, and since we have the AB here, 2AB cosine angle C. So C squared is 9 squared equals A squared, 11 squared plus 6 squared minus 2 times 11 times 6 cosine C. So 81 equals 121 plus 36 minus 132 cosine of C. This is 157, so we'll subtract 157 from both sides, and we get negative 76 equals the opposite of 132 times the cosine of C. Divide both sides by negative 132, and then we will have cosine negative 1, the arc cosine of angle C, equals the ratio negative 76 over negative 132. So now we've got calculator ready form. So we can put this in our calculator. Second, cosine, well, negative divided by a negative is a positive, so 76 over 132, close parentheses, and angle C is 54.8 degrees. So that's the measure of angle C. Let's go on to our second sample problem. Solve triangle ABC. If angle B is 73.5, side A is 28.2, and side C is 46.7. So we have our particular triangle, and here we have side, angle, side. We can't use the law of sines because I don't have the side opposite the angle I know, and I don't have the angle opposite the sides I know. So I've got to use the law of cosine. So this is important. First thing we're going to do is we're going to solve for the main side. So we're going to solve for side C. So we're going to use our law of cosines that involves C squared. Okay. Use the C squared equals C squared plus B squared version again, minus 2AB cosine C. Oh, and I made a mistake. We're not going to solve for side B. We're going to solve for side C. We're going to solve for side D. So we use the B squared equals A squared plus C squared minus 2AC cosine B. That makes a little more sense. We're not going to use that one. Let's use the second one. So we'll be able to do this pretty quickly. So B squared equals A squared plus C squared. So 28.2 squared plus C squared, 46.7 squared minus 2 times 28.2 times 46.7 cosine 73.5. But I don't want B squared, I want B. So I'm going to take the square root of both sides and solve. And believe it or not, this is already in calculator ready form. So I'm going to pull out my graphing calculator. I'm going to input this all in. I want the square root of the entire quantity of 28.2 squared plus 46.7 squared minus 2 times 28.2 times 46.7. Take that out. And now enter. And now I've got the correct answer, 47.20. So inputting everything correctly into my calculator, I get 47.2 for the length of side. And we are set. So now the next thing we want to do is we want to solve for the smaller angle. Okay, so we use the law of sines and solve for the small angle. Well, the smallest angle is going to be opposite the smallest side, so that is going to be the 28.2. So the smallest angle, sine of A over 28.2 equals, I have to use the sine of B, sine of 73.5 all over 47.2. So sine -1 of A equals 28.2 sine of 73.5 all over 47.2. I input that into my calculator and I get angle A equals 34.9. So then I know the two angles of my triangle. I now have calculated the 34.9 for angle A. And then angle C, of course, is the remaining number of degrees. I can just use my sum of the interior angles of a triangle formula, and I get 70.6 for angle C, and I have solved that particular triangle. Let's go on to our final sample problem. Solve triangle ABC if A equals 25.4, B equals 42.8, and C equals 59.3. So here I have side, side, side. I have no angles, so once again I'm going to have to use the law of cosines. So our process here, if we have all three sides that we're solving, originally we solved for a particular side, but now since we don't want a particular angle, we want to solve for the largest angle. So solve for the largest angle first. Okay, so The largest angle in this case is going to be angle C. So do that angle first. So we will use C squared. So 59.3 squared equals A squared plus B squared, 25.4 squared plus 42.8 squared, minus 2 times 25.4 times 42.8 cosine of angle C. So 59.3 squared is 3,516.5 equals 2,477. That's the 25.4 squared plus 42.8 squared minus 2,174.2 cosine of C. Subtract 2477 from both sides. And we get 1,039.5 equals the opposite of 2,174.2 cosine of C. Now this is multiplication, so I need to divide by negative 2,174.2. So I get cosine negative 1 of C equals 1,039.5 divided by negative 2,174.2. I am in calculator ready form. I can input that into my calculator and I will get angle C equals 118.6. So that is my largest angle opposite my largest side. I've got an obtuse triangle here. So now all you need to do is use the law of sines to calculate the largest remaining angle. Okay, so use the law of sines to calculate angle B. And since you already know the law of sines, I will let you take care of that. And then also find out what angle A is. So why don't you solve the rest of the triangle? And I will see you in class.